second day of skill development program. And today we are going to learn about landing skills, how to design landing skills using free CAD software. So without wasting much time, I hope you are all having the software with you. We will be starting the session without wasting the time. I request Girish sir to start the session.
Thank you, sir, and good evening, everyone. Today, our session is about the landing skis for the aircraft. So, these landing skis are basically landing gears for the aircrafts which are to land on water or ice. Like some helicopters have their landing gears not as a wheel or struts. They have skis like it is a structure like bottom of the boat, which helps the aircraft to land on a water like this one. If you can see, the figure must be little blur. This part, it looks like a boat or the bottom of the boat, which helps the aircraft to land on a water surface or icy surface. The most of these type of aircrafts are called amphibian aircrafts. Some of them also have some wheels out there, so that if they have to land on a surface or on the land, they can land in on the surface also as well as on the water. And these are made up of such a material which is capable of floating on the water, and shape is also aerodynamic shape, which will help it both for the water as well as in the air while it is flying. You can see its shape. It's like aerodynamic shape only. So today we are going to construct these struts by which it is attached to the aircraft and the main body of the landing skis. These are of two types. One is this, and for the icy surface, which they have a flat one, like the ice skates you have seen in movies or anywhere. The ice sports games like that. So this one is for water, and for icy surface or snowy surface we have the flatter one, which you have also seen in the movies for the ice skating or ice hockey pl- sports. So first we will do with this water one, and then we will also design for the other one for icy surface. Hope till now you have understand what we are going to construct or design today. So let's start with our design. We will use our FreeCAD software. This software is open source software. We don't need any license for this, and we can use it as it is. It is very similar to SolidWorks or CATIA with some limitations and some. Every software has different platform and different interface and different features. So it is very much similar to SolidWorks. When we open a FreeCAD software, this window will open. This is the first user interface or for welcome page for the software. We start a new project by clicking on the new, and from here we will choose what we are going to do, like drafting, drawing, some FEM testing, inspections, meshing, all that. Today we are going to design a part. So first select the part design. As soon as you select the part design, it will take you to the platform where the a part will be designed, and all the features are highlight came up to the status this bar. Okay, so for a part we need a body, any solid figure which is a part. So first create body, and to create a body we also need a sketch, because without sketch we won't have we won't we will not able to create a body or 3D figure. So create sketch. Now it will ask you to select a plane on which you are going to construct or draw a sketch. First, I will take it to isometric view like this, and I will take exact plane. That would be our front plane for these keys, and then OK. So how it would be looking like from the front side? The exactly like this. This would be the front side. Not for the aircraft. This side would be the front side on the propeller side. But for the skis, which we are going to construct, this side would be the front side for now. As per the requirement or as per the situation, we have different directions which we say for front view or side view or other views. So let's start. First, we will take a straight line. I'm taking from here to here. Escape. I will give a vertical distance of this point with the center. That would be 0 and enter. So that it remains to the center. Then select it and make it horizontal. Now we have a horizontal line. We have to give these constraints by ourselves. They are not automatically given. Then we need a 3-point arc like this. Escape. This is also free. So select both of the points and make them coincide. Let's give some length to this line first. Selecting length, let it be 60, which is already given, and horizontal distance from the center to this point I would like to give it 30 so that it is symmetrical to the central axis. Now just zooming in a little bit. Now adjust this like this. Okay. Now from here you can see I have made this straight line and this, though it needs to be curved here also. So what I will do, remove it and first make that curve also. Select it here and this. Okay. I will make this arc and this line tangent. Where is tangent? Here it is. This command is tangent, making both of them tangent. Now it will be tangent to it. Okay. Here I would like to make a little circle. Escape. This circle plus this arc also be tangent, so that I don't have a sharp edge here. I want it to be a curved edge. That's why I have make a circle there. If I choose another arc, and it will make like something like this. If circle would not be there, the other arc would be like this. A sharp edge would be there. So to remove this sharp edge, I have chosen a circle first. And from here I will make another arc, the lower arc. Take it at this point to this. Okay, then we can adjust it First make them tangent. Then this point over it, select both of them, and this fixed point over this object, like this. Similarly, this point and circle done. Now reduce the radius of this circle. Now you can adjust this.
Sir, you are muted.
Sir, your mic is mute.
Yeah, now I'm audible. Hello, hello.
Yes, sir.
Okay, I have done this one, and that circle was to make remove that sharp edge. If circle would not be there, it there would be a sharp edge. Just to remove that sharp edge, I have used this circle. And here we can also fix the radius to be 2, and radius of this arc, let it be 89 only, and to this let it be 17 only. By the way, for now we don't need these dimensions, but I am giving just for your reference. If you want to take reference or exactly same way, you can take it. Now the third arc would also be there, but should be much straighter or little bit tilted upward.
Sir, again your mic is mute.
Yeah, now it is audible. So here we have a straight straight curve curve, or you can get straight line. This one I have made this part, then a little bit up, then a slanting line to conclude it. Make it horizontal like this. Then again we have another line here which is vertical. This is also free to move, so add some constraints here like this. I am moving it there. Then this landing line, select these 2 points and coincide them with the close figure which is required. Okay, and another line. Now we can take a polyline to complete this figure. Select these points and make them coincide. Similarly, these points would also be coincide to make it a closed figure. And now this one is horizontal and this would be vertical like this. Make these two lines also tangent. Now you can see. Here we have the front view for the landing ski. Okay, so now what I will do, just came out of the sketcher and make it 3D. Yeah, this is auto update is on for me. I have turned on this auto update so that I need not to update after each and every sketch. If it is not on, after every construction or every constraint you have to update the sketch. So before starting you can or turn it on, or you have to update. So that's I have turned it on earlier, so I don't need to update. So whether it is showing 9 degrees of freedom, that means it can move easily up and down here and there. So by giving some dimensions we can reduce degrees of freedom. It won't be movable. Let me show how. This one I'm giving a dimension, let it be 35 only. Okay, then this one, let it be 4. Then just placing these dimensions out so that we can choose other dimensions. Now you can say I have given these dimensions, so degree of freedoms has been reduced like this. As you keep on giving dimensions, it will keep on reducing the degrees of freedom. Correct. We can give a vertical dimension to this one also, like this, and placing it out. Now you can see degree of freedom reduced to 5. For a fully defined and perfect sketch, you need degree of freedom to be 0. It should be 0. Okay. So for now, we can leave it as it is, uh, and you can give degrees of freedom afterwards to this. You can here I am going to give this one also. This dimension, let it be 2.5. You can see it reduced to 4. As I keep on giving these freedoms or these dimension, degree of freedom would be reducing. It
Sir,
left.
please speak loudly, sir.
Okay.
You are not audible.
To use these degrees of freedom, you need to give dimensions. As you keep on giving dimensions, the this degree of freedom would be reduced. And for a perfect sketch or a fully defined sketch, you need 0 degrees of freedom. That is, the figure or sketch you have made will not move here and there without your permissions. So for that you need, and the color of the sketch would also be changed to green. Now still 3 degrees of freedoms are left. We have to check out which dimension I should give, which will reduce or which will give it more stability. You can see it by two ways, whether by the stability, more stability, or less degree of freedom. And placing of dimensions is also important while making a sketch or anything, because these placements should not intersect your sketch and should not interfere with your sketching lines. Here I have, like this, I have given this dimension which is intersecting the sketch. It should not be there. You can keep it like this and move it to this point so that it won't intersect. And now what we can do, we can give this horizontal so that it can, sorry, vertical, let it be 30. Now two more dimensions are required. Let us try to give this one. Let it be 40. Yeah, one more dimension and it would be fully defined. Let it be this one. Okay, you can say, as the degrees of freedom would become 0, the sketch color of the sketch is also green. This green indicates that the sketch is fully defined, no more dimensions are required, and it won't move like this. I have selected this and trying to move, it is not moving. Okay, so no need to update as auto update is on. If you do not turn on this auto update, you have to update after every step. So it is completed. Now close and come out of the sketcher. Here we will make it fail. Some broken faces are there. Okay, then cancel. Enter into the sketch and look out for the broken faces. I guess this one. Yeah, here it is broken. For that, select these two edges. Okay, now we can make it 3D. Still there's some broken edges there. I guess this here from here. Select this sketch, move it a bit, zoom in here. It is not broken. Yeah, it is broken. Select these two, coincide. Let me check. This one is also broken. Select two and coincide. Hope no other face is broken. Yeah, need to make it coincide. Okay, fine. Make it horizontal also. close it, and now we can make it 3D like this. I will make symmetric to plane. That is the plane y xz plane we have chosen. 10 mm, 5 mm would be on the right side and 5 mm on the other side of the plane we have chosen. So let me increase this to 20 mm and okay. Make it zoom to fit. So 20 is much more. Let it be 10 only. 10 is fine. If you want to see exact plane, it would be at the center. Okay, it would be at the center of this figure. Now this is not that like that. We need to remove the all the sharp edges. For that we have fillet command, which will remove the sharp edges. So for now, I'm selecting these edges first. Okay, I'm applying fillet to these edges first. You can see. So that sharp edges has been removed to a curved and round edges. Similarly here also these two, and rotating it a bit. Sorry, keep it selected with help of control. Rotate it and select this one also along with this and make a curve. Here I will choose bigger curve. Let it be 1.5. Uh, Here you can see we have curve shapes and no more sharp edges are there. Okay. And one more thing, these are always be hollowed. Okay, these floats, you can say floats or the skis are hollow in nature. They don't have the solid material. They are hollow, so having air so that it can be placed over the surface of water. It do not submerge in the water or submerge, partially submerge. It can lift, take the weight of aircraft and float over the water. That's why they are hollow by nature. And the material is somewhat which are used in the boats or ships. So now we are left with struts which are going to attach with the aircraft like this. We have two struts there. In this figure we have two struts. You may have one, two, you may have three, or you may have two, depending upon the which type of aircraft you have. So let's start. We will also make two struts only. On this surface we will sketch, you can see this space xy, it is at the center of the figure we have made. Okay, just placing at the center and zooming in. For struts we will need a circle, or two circles. One is at here and the second one is here. No, uh, so give them a horizontal dimension between these two to be 20, and from this to this to be 10, so that it would be symmetric to the center. The symmetry is very much important in the while designing any part or component in aerospace. And then We will give radius to these circles. Let it be 2, and this one also be 2 on a scale, giving vertical dimension with this axis. There should be 0 and like this. You can see we have a green circle there. So close it and extrude this. 10, 15 would be enough. Okay. We have these struts which are going to attach with the aircraft. So on the YZ plane, I am again going to construct some that angles which are going to attach with the aircraft. So it's Z plane. How I am choosing the plane, you can see from here. This is ZX plane. I need to work on this, and from here you can choose the plane on which you want to work. Taking a polyline, right? Just giving some of the constraints required to complete this figure. Horizontal, like this also vertical. Let me check now. It's fine. Close and rotate it around this. One just like this. Just no, I can't rotate it about this, so I need to make it separately or with different method. Select this and delete. Just sketch. I am unable to select this. Okay, these struts are made. Now on this surface, we will make that flat plate which is screwed to the surface of the aircraft. So I'm taking another plane. Wait a second. Pencil horizontal XY XY plane and take another plane. Now move it in Z direction. Here. Okay. Now on this plane we will sketch. These are the planes we can choose or we can make for the construction, and these planes we can use for constructions. Okay, these are called atom planes, and you can hide these planes. These are just you constructed for the construction only. They are not part of the any figure, any object, any component. These are just imaginary planes. So over there I'm making a flat plate which is going to be attached to the aircraft. Okay. Over there we would have our slots for the similarly here would be 8 and it would be 5. Now this should be vertically 2.5. Similarly this point also be vertically 2.5. Now it is metric. I need to make the sharp edges to be curved. All the four, sorry, 8, the 4 for this and 4 for this figure should be removed. Okay. Now close it and pad this up to 2 mm. Okay, and then rotate it a bit. Select this plane, right and spacebar. Select this plane, spacebar. It would be hidden. Now that plane would not be shown to you. On this surface again we will sketch for the holes to screw. 1, 2, 3 and 4. Similarly here. I'm just not giving dimensions to these holes which are to be used for screws. I'm making this just for your reference. You can give dimensions with symmetry also. You have to take care of the symmetry as well as the dimensions. All the 8 holes should be of same dimension. Leave it and make a pocket. You need not that much. We have 3 mm would be enough. Now make it isometric. And you can see this. Here we have holes for the screwing purpose. Or you can also change the dimension. So this pad. here. Zoom to fit like this. These are the pads which are going to attach to the aircraft, and these struts. After that we have skis for the landing in the surface on the surface of water or to float. You can see this figure. These are same. It is similar to this. Let me show you from this side. Yeah, you can see these are same. Fine. So these was our landing skills for to make a aircraft float over the water surface of water. Hope you have understand all the things we have done. If you want a ski for the icy or snow surface, you just need to make. I am going add a body here, new body. Okay, and on this body I will ZX and sketch. I'm just telling you a sketch which will replace this one. The first step would be replaced for, and like this sketch would be there. Then the straighter one, then a curve would be there, and another curve like this. The first sketch we have made this one. This sketch would be replaced by this sketch for the icy or snowy surface, and then the other steps are same. If you want to make a figure for the snow or landing skis for the snowy or icy surface, these are somewhat similar to the ice skates. So that's all for the today's session. Hope you have understand, and if you have any doubt you can ask me. For now I am removing this one. We don't need this. This is our main figure which we required and which we have designed today. Anyone having any doubt you can ask me. No question, no doubt. Have you understand all the steps? No doubt means you have understand everything or you haven't listened anything.
Girish sir,
Yes, sir.
Girish sir,
Yes. Hello.
if anyone having any questions, you can ask in the chat box. If anyone having any questions, you can ask in the chat box. Okay, fine. So we can end the session for. Yes, there is a question, sir. Can we do it on a CATA V5?
Yes, sure.
Okay, sir. We can end the session. We can join in the tomorrow session at the same time, 6 o'clock.
Okay, sir.
So
Thank you very much,
we
sir.
will end this session. Yes.
Rather, this is possible with the same commands in CATIA. You have